All right, why don't we get started? It is a great pleasure today to be introducing Hanuma Kodavalla, who is technical fellow for our SQL database business. Hanuma has a long and distinguished career in the database field, having shipped products at multiple companies. He was working at Data General, at Digital Equipment Corporation, where he worked on RDB VMS. The first time I got to know him.
RDB Star, Phil.
RDB Star. You did hard.
RDB VMS.
We never recruited you to RDB VMS.
Jim tried to recruit, but you know how the two teams.
Well, thank you for the correction. Where was I? And at Oracle, at Sybase, at Acera. He's been at Microsoft for the last 20 years and has been leading the SQL Server engine business. So he has a deep knowledge both of the product and its history of how it came to be. And he's now going to tell us the long road to take it from being an on-prem database system to being a successful database system service. And with that, let me hand it over to Hanuma. One comment is we plan to make this this talk, the recording of this talk, public. So keep that in mind if you ask questions. Thanks.
Thank you, Phil. I gave a talk at VLDB 2022 in Sydney, Australia. C. Mohan invited me to give a talk on our experience in evolving SQL Server to SQL Azure. That was a 30-minute talk. So recently when Phil asked me to give this talk, I said, okay, I can make use of the full hour and do full justice to all the stuff that we have done. So thank you, Phil, for the opportunity. It's always a pleasure to come to MSR and give a talk because almost everything we do is in collaboration with you folks. So it is our combined work, and we take a lot of pride in the culture of SQL to work closely with MSR right from the inception of SQL product group. As Phil mentioned, we want to make this talk externally available. So after the VLDB, I posted the slides on LinkedIn. A lot of the people wanted to have access to the video, but for various technical and non-technical reasons, VLDB was not making it available. At least they want to wait for a few more months. So the reason I want to make this available is I actually want to have our colleagues, both within and outside of Microsoft, to share their experiences. I mean, obviously, we publish papers on interesting ideas, but there's a lot that we can learn by sharing our experiences in running a service. And I feel that is something that's normally not well represented in the conferences. So I hope by making this available externally, we can encourage other people to do the same. So as you all know, SQL Server has been a leader in on-prem RDBMS market. I mean, everyone talks about the cloud, but let me just give an anecdote. 2-3 years ago, I'm sure it's before the pandemic, I was at Costco, and one of the ex-SQL Server persons saw me and said, oh, how is SQL doing? And he said, are really people still buying SQL Server on-prem? I mean, this was 3 years ago. People thought.
Getting your slides into the Teams note.
So people thought we already moved to the cloud and there's no more significant business on-prem. Not true. SQL Server has a strong and very healthy on-prem business. Actually, just before this meeting, I was coming out of SQL 22 release meeting, so we'll be shipping another major release of SQL next month. It's a very, very healthy business. Of course, it's not growing in like cloud business, but it is healthy, and we expect that to be the case for many years to come. And that's the reason we invest in shipping on-prem releases. In fact, within engineering, we don't have separate teams for on-prem and cloud. It is the same SQL engineering group that ships on the cloud, and whatever is running on the cloud, we once every 2-3 years we ship on-prem. So what's the big difference between on-prem and cloud? And I mean, you all know that we talk about elasticity. Customer doesn't have to do provisioning and so on. But there's one big difference. When customer buys on-prem, they are managing SQL in a very controlled environment. I was actually trying to get some data about our on-prem business. So I said we will be shipping SQL 22 next month. The last major release was SQL 19, shipped about 3 years ago. Prior to that, we shipped SQL 17 and SQL 16, SQL 14, SQL 12, and so on. So the number of paid instances on-prem on SQL 19 is less than half of all the instances on-prem. So customers take significant amount of time before they upgrade to the new release because they're worried about any changes happening. Whereas in the cloud, we are shipping new bits every 2 months, and that is a huge difference between on-prem and cloud engineering-wise, and it poses a significant number of challenges, and I'll go through some of those. We had to make some architectural enhancements as well as things related to operational issues in managing a big service like SQL. And we have made innovations in all areas of RDBMS across the whole stack, and I'll give at least one example in each of the areas. I mean, even though we do learn from research, being familiar with the code base, talking to the customers, there's also quite a lot of innovations that we made directly based on our experience in running the service. So that's something I want to emphasize. So let me give a brief idea of at what scale is SQL Azure. SQL Azure, SQL DB, they are synonymous. It's the same core engine that is shipped in both on-prem and different SKUs in the cloud. It's available in all geographies in the world, and within each major geography we have multiple regions, and within each region, in many cases, we have multiple availability zones. And there are some special regions in various parts of the world for US Go, because they want to run in a highly protected manner. There are data centers in China that don't give access to all the folks. And in some other countries, for residency reasons, there are special data centers. Some of these pose challenges. I'll tell you about the live site culture that is there in engineering, but for some of these data centers, when there is a problem, it's not like me or my fellow engineers can directly jump onto the bridge and fix the problem, because you need to have a very high level of security clearance to be able to deal with these problems. So it goes through the first set of engineers who have the clearance, and then they have to talk to the engineers that have more expertise in the product. So there are more challenges when you have to run in some of these special regions, but we do that, and it has actually expanded over the years. And to get an idea of how many databases are running in SQL Azure, at VLDB I said 10 million plus, and I just checked while preparing for this. We have more than 11 million databases in SQL Azure. So we, meaning the Microsoft engineering customer support, is responsible for managing this many databases. And we have at the entire spectrum, from very small databases with less than a gigabyte to close to 100 terabyte databases. Many databases are used for dev test. Of course, SQL Azure is used by mission critical customers. Microsoft itself critically depends on SQL Azure for running their operations. There are some major partners within Microsoft. Their whole fleet runs on SQL, for example, SharePoint Online and Dynamics. It's fully managed. We take care of auto scaling, automatically doing the upgrades, taking the backups, and so on. And we honor all the legal and other compliance requirements. It's monitored 24/7 throughout the year. We have people across the world, in US, in Serbia, and in IDC, significant engineering groups. Serbia has been there for more than 10 years. IDC, we have invested heavily in the past 2 years. So now we are able to follow the sun model so that we don't have to have Redmond people staying up in the nights. It has been a huge savior for us. Life site culture permeates throughout engineering, service first mentality. If you're on call, if you're in a meeting, if you get called, you have to just go and attend to the incident. All high severity incidents are reviewed in weekly meetings at all levels. Every week, Peter Collin reviews the high severity incidents in the services. If there are several ones, they may get reviewed by EVP like Scott. For each such incident, there are repair actions identified, and we give high priority to those items so that the same problem should not appear within a reasonable time. So that's how we prioritize the engineering investments. Never lose data is the primary mantra in SQL. Customer data is sacrosanct, so we should never lose customer data. Tremendous amount of telemetry is gathered for various purposes, for root causing the problems, for helping the customer, as well as for feature development. Unlike in the past, if you're trying to develop a feature, we ask a lot of questions. Okay, how many customers are seeing the problem? We actually spend a lot of time adding telemetry that will help us in taking the right design level decision. So it's a big change compared to, say, where we were 6-7 years ago in SQL.
Question.
Ravi.
In your experience in this incident, understanding and how to handle these incidents, right? Is it still very human-centric, or what fraction of this can be automated, has been automated? Is it still a very human-centric operation?
For recording, the question is how much of incident management is automatic versus manual. It is work in progress. We continually improve on automating. Significant number of incidents are automatically handled. We can actually give proper explanation for the customer. There is Azure Service Portal, something like that. Within engineering also we do automatic mitigation, but a lot of the SAV2 incidents do require manual handling. And this is something that we do as part of reviewing the incidents. How can we automate that? It's indeed the case that we have done a lot of work in automating. If we didn't do that, we wouldn't have grown to 11 million databases. The engineering, we hired a lot of people, but of course not in proportion to the way the service has grown. So clearly, we make a conscious decision to make sure we are automating so that we are not stuck with just doing incident management.
We have an online question. Is it Tariq?
Across regions they're deployed, right? So do you also have to tune these databases specifically to different customers? And there has been a lot of research recently on automatically figuring out the right knobs and their configurations and those things. So do you see that as a problem in the existing infrastructure, like the way you deploy it, do you have to like configure it on a per customer or per use case basis? And if you do that, and how do you go about doing that tuning?
Yeah, it is difficult to do per customer based tuning, but it is definitely an area where we all need to improve the databases so that customer doesn't have to deal with configuring various parameters and so on. So today, if a customer complains about some performance issue, then we investigate and we say, okay, some index is missing, or you need a higher level SKU and so on. But it's based on any incident that we get into. We have done some features to automatically figure out, for example, I'll talk about it later on about max DOP and stuff like that. But it is still the case, customers have to do the indexes. We do recommendations. We don't go and automatically do all indexes. So I mean, for the database community as a whole, I would say that this is an area where we need to continually improve so that various knobs that we have are automatically chosen by the system based on the workload.
Thank you.
About the debugging and the root cause analysis. Just curious, like how often do you see like severe one incidents, and then like what are the consequences, and like what are the like usual costs?
SEV1 incidents are rare. Yeah, how rare are the SEV1 incidents, and what are the reasons for them? They are rare, but at the scale that we are operating, I mean, once in a month, is it rare? I mean, it could actually cause significant issue for the customers. Why do they happen? If you look at SQL itself depends on so many other services from Microsoft, and everyone is continually making changes. So a bug may creep in, not necessarily because of SQL. The number of SEV1s that came from SQL mishandling, I would say maybe it happened once in the last 3 years or something like that. But there could be a SEV1 because say someone rolled out something from networking, and that's causing significant outage in a region, so things like that.
I'm just curious, how do you characterize something as SEV1 versus SEV2 versus SEV3?
We have a criteria. If it is SEV2 is for a customer, if they're seeing a perf issue or the database is down, that's SEV2. But if the issue is affecting more than some number of customers, then it is SEV1. Yeah. SEV1 means all hands on deck. Right? You don't have time to go to Costco also. This picture shows the two major SKUs that SQL offers. They're called Premium and Standard, also known as Business Critical and General Purpose. In case of Business Critical, the data is stored on local storage. We have 4 replicas in case of Business Critical, and that's what we recommend to the enterprise customers. In case of general purpose, the data and log are stored in remote storage, in Azure storage, and there's only one SQL instance. If there's a crash, then SQL has to be restarted. But we support geo-replication in both SKUs. In case of standard, it is storage geo-replicating. In case of business critical, SQL is replicating the log to the other side. There is a symmetric configuration on the other side, which is applying the log. And this is something that I was surprised to learn when I started working on the cloud. I thought typically customer would choose a BC or a standard and then would stay with it. But thanks to cloud, customers are always willing to try novel things to save what they pay. So a lot of the customers, they may decide to go from BC to GP when the workload is on the low end, maybe in the nights or weekends. So this kind of scaling up and scaling down is fairly common amongst the SQL customers. And we support this by basically doing a restore of a streaming restore of the database backup. I said it is a fully managed service, so we take backups, full backups, differentials, and log backups every few minutes, and the backups themselves are stored redundantly. They are replicated locally. You can also replicate them across the zones or across regions. We support two types of retention: short-term retention for up to 7 to 30 days. Typically used if customer made a mistake, dropped a table, or I mean, sometimes if we had a bug, then we want to actually debug, then we go and do the restores. But we also support long-term retention where the backups are retained for up to 10 years, and there are some customers that need this for legal compliance reasons. In particular, in healthcare, they need to keep the data for 10 years, and I'm sure in clinical trials and other places they need to have this. So we support both. I want to share one incident. So I said we always take the backups automatically, so there's no choice for the customer to say, okay, don't do the backups. In case of data warehouse, they don't do the backups because it's more expensive for them. But in SQL Azure, we always take the backups. I remember during early in the pandemic, one of the customers who migrated from SQL on-prem or from some other customer to SQL Azure, they were seeing that they were paying a lot of money for log backups. And the customer complained, hey, my database is idle, why are you charging us? Of course, internally, I mean, even if the customer is not doing transactions, internally there's a lot of background activity that generates log. But the customer said, hey, we just migrated to SQL Azure, and it is the business is a small business. They run some number of gyms, I think in Brazil or somewhere. But it was early in the pandemic, everything was shut down, right? There were no customers coming to the gym, so the business was not making money, but SQL was charging for the log backups. So customer was not happy. So, and we were wondering, why are we doing log backups if there is no real activity? And then we found out there is a garbage collecting thread that wakes up, and it does a begin tran, commit tran, even if there is nothing in the transaction. So we had to fix that, and the customer was happy. So we recommend availability zones for business critical customers. It protects against various disasters like fire, flood, and power outage. Surprisingly, these things happen almost regularly. When I say almost regularly, since it is a global service, there could be a flood in South Africa this week, there could be a power outage in Pune, India next week. So we do see a lot of the incidents where some disaster has happened, and geo-replication has indeed helped. So we recommend to the customers. One of the great examples I remember is early last year, there was a major, Jonathan?
Oh, when you're ready. I don't want to interrupt your flow.
No, go ahead.
I just a quick question. Do you ever leak results of transactions that might not be recoverable? Like in the event of a disaster or something like that, does every piece of leaked information, is it always geo-replicated, or is that not something that you're trying to do?
Every piece of?
Every piece of information that's leaked outside the data center, for instance, a client that's sitting in a customer or something, is it guaranteed to be geo-replicated before you, for instance, say a transaction commits? Is it guaranteed that it's recoverable somewhere else other than the data center?
Yeah. So Jonathan's question is, are transactions committed only after they are replicated, even remotely? That's not the case today. I said we have 4 copies in, say, in case of business critical. We make sure that we have a quorum commit locally, and it has a customer can choose to have geo-replication, but we don't wait for this transactions log to be replicated to the geo before return to the client. So, I mean, there's a significant latency when you're geo-replicating, so it's not acceptable to wait for the commit to reach the other geo. So we don't support that today.
They turned up the mics in the room, so you shouldn't have to repeat the
All right.
questions.
Okay. Thanks, Phil. So one of the incidents I was referring to was early last year, there was a major storm in Texas. We have a big data center in San Antonio, and it was a sub one. So it was a sub one for most of Microsoft because almost all services have presence in San Antonio, right? And company was trying to do its best to make sure there's no power outage, and we were even bringing diesel generators and stuff like that. The service was not done, but we could see that there would be problems. There will be problems in communications and so on. So one of our major partners in Microsoft is SharePoint Online. The other one is Dynamics 365. SharePoint Online just doesn't tolerate any loss of availability. They're okay actually losing some of the transactions because they typically store metadata in SQL. They don't want their systems to be down. So as a precaution, we moved tens of thousands of databases from San Antonio to another region. Around the same time, there was a storm brewing on the East Coast, so we couldn't actually move them to East Coast data centers, but we found enough capacity in other regions to move. And we did all of this without SQL or SharePoint Online customers knowing that this thing is happening under the covers. So that's a great experience, and hopefully customers see the benefits. So now I want to talk about a few improvements that we have done and background for at least some of them. So this picture shows at a high level how our business critical offerings architecture is. There are 4 replicas. 1 is primary, other 3 are replicas locally, maybe in different availability zones, but in the same data center. So data and log are stored locally. Only primary is responsible for the writes. It will send the log to the replicas who are continually applying the logs. And as you can see, the entire database must fit on the local storage. So 6-7 years ago for SQL, I mean, the service was still in its early stages. Most of our databases were small. I mean, 100 gigabytes was kind of on the large side. And even the hardware we didn't have terabytes of local storage. But we could see that the service was growing and customers were gaining confidence, so we knew that we would get workloads that would require larger support for larger databases. But with this architecture, since the entire database is stored locally, if a primary goes down and if you want to create a replica, you have to actually copy the entire database from one of the replicas. So this kind of database size operations would be untenable once you get into multi-terabyte databases. So we recognize that this is a problem. And similarly, if people want to dynamically change the size of the SKU, that becomes a database size operation, which becomes really hard. So we started a major re-architecture project called Socrates, also branded as Hyperscale, where we decouple the compute from storage. So you can see on the compute, we have a primary compute and some number of secondaries. And then there are page servers that are responsible for some part of the database. And then there is a log service that's responsible for storing the logs. So we completely decouple the major parts of the database engines. This is a huge effort. It took more than 3 years. So with this, there is no limit on the size of the database, and we can quickly create replicas because there is no local storage. And it also gives us better availability because the storage is distributed. If a page server is down, only that part of the database is not accessible, and we can quickly restore that because it's not a large data part of the database. And one of the major things whenever doing the architecture is one thing, but nowadays customers don't care about how great your new architecture is, right? You want the customer to migrate to this great new architecture, but they expect you to do that without any downtime. This is a major effort to, if your database size is say beyond a few terabytes, then we recommend people to move from BC to hyperscale. In fact, within Microsoft, some of the sales databases and some of the big customers of Dynamics, they were reaching those limits on business critical, and we have been migrating, and we have been very successful in doing this without it causing any downtime for the customers. And today we have close to 100 terabyte database on hyperscale, which just would not be possible even if we had the hardware to support using BC. Arvind?
So, what's the difference between the architecturally? What's the difference between Socrates and the other offering that you mentioned, where the storage is anyway remote, right? The non-premium offering.
Yeah, that's called general purpose.
General purpose.
Yeah. At least two. One is in case of general purpose, there is only one instance, and the database file is remote. If that instance fails, now you need to start another process. In case of hyperscale, one of the secondaries can become the primary. The second thing is the storage it's not local, but there are these things called RBPX caches that you see, the orange boxes. So some part of the database is locally cached. So that gives us enough performance advantage. In case of general purpose, we always have to go to Azure storage if we don't have the page in our buffer pool. So that's a significant profit for the enterprise customers. Yeah. So let me talk about overbooking. In the early days of SQL Azure, the resource allocation was static. You ask for some number of cores, some amount of memory, some storage, and we find a node that has that kind of resources, and that's where we will run our database. And if we don't have we need to have the resource that the customer has asked for. So this has caused significant problems because sometimes we may not have the capacity. In fact, when we are doing upgrades, then we need to bring down certain nodes, deploy the new bits. So during that time, we need additional hardware to keep the service running. So we could not actually sell all the capacity that we have because we need to reserve something for upgrades and failures. So what we have done is, this picture shows at a high level what is the architecture of SQL Azure. There is what is called tenant ring, which is a collection of compute nodes that are managed by a cluster manager. In case of Microsoft, it is Service Fabric that is responsible for managing this. And on each node, we have some number of SQL processes running, managing databases. We have a resource governance manager running on each of those nodes, and it is responsible for figuring out, okay, what is the resource usage on each of the nodes. And then there is making use of Service Fabric, and knowing the history of customer workloads, we can actually oversubscribe. Because if we have a lot of telemetry to show that most of the times the CPU utilization is below 40%. So if we know, if we have the global view, in this case global view is at least, let's say, on this tenant ring, there might be many nodes where there is extra capacity. So we can actually move move the databases around this node so that the customer does not see that they're affected. So we can actually do the overbooking by making use of the slack that's available on various nodes. Jonathan?
Do you still offer to customers the ability to sort of just say, well, I want to pay more, I want you to overbook, and I'm willing to pay just to make sure that there's always the capacity that I need?
Today we do this only for I mean, there is a provisioning mode. I think for BC it is actually provisioned, so we don't do the overbooking in those cases. If Ajay is online, maybe he can give a better answer. Ajay?
Yeah, hey, hello.
Do we give
It's good.
option to the user to say that, okay, I'll pay for all the cores and whatever resources that I need,
No.
and don't? Oh, we don't.
Yeah,
Okay.
no, we don't.
So this picture shows to what extent we can do the migration. Within the node, we can adjust across different SQL instances. But with Service Fabric, we have the knowledge of resource usage across all the nodes in TR, so we can move across the nodes in the TR. And sometimes we can move across the TRs also, but as you move towards the TR and region level, it becomes more expensive because you need to move the entire database say in case of BC. So serverless is a popular theme amongst cloud vendors. There's a good anecdote I read, analogy, with cars. In the good old days, customer buys the computer and manages software, hardware for a number of years. So that's like buying a car. You buy the car, you're responsible for maintenance and so on. In the cloud, you can rent a VM. So that's like renting the car. You pay on a monthly or a weekly basis. You can also take this serverless offering where pay for use, which is like taking Uber. So this is something that we announced 3 years ago, and it's one of the fastest growing offerings from SQL Azure. So you can see that for most customers, the workload, I mean, during the business hours, they're making use of all the cores, but as the business day ends, the usage goes down, and at some point there is practically no activity on the database. So what we do is we actually detach the database when it is not being used, and we don't charge the customer for till the database is activated. So that's something that's offered only in certain SKUs, but this is what we want to make sure we are doing across all of our services. Okay, when I moved from managing the box development to the cloud, one of the first things I remember was there was an incident where database went down and it was taking a long time to recover, and people were saying we should fix it. And I said, yeah, it's a known problem and customers should not do it. Why are they doing some long running transaction or something like that? Then my colleagues who had been on the cloud for much longer, like Ajay, Peter, Colin, and Tom, said, Hanuma, this is not customers' problem, it's our problem, because if they were running on-prem, then they plan. I mean, a lot of the business customers, they do have legitimate need for batch transactions, end of the quarter and things like that. But they do plan those things when there is no other activity and there is no other maintenance and so on. But when they're running in the cloud, they don't have control. I mean, we are actually doing upgrades. We try to honor some of the maintenance windows, but there are times where we are moving. For example, I said about overbooking. So there might be some cases where we may have to move the database to some other node. So we may cause downtime. Or there is a significant bug and we say, okay, we are going to roll it out. And so we might bring down the database in the middle of some major transaction. So we said, oh, this is a significant problem if you're going to manage at scale, so we need to solve this. So we re-architected SQL Server's recovery so that regardless of whatever is running on the system, recovery will take a small number of minutes, ideally less than a minute. The way we have done this is we maintain versions in a persistent way. I mean, SQL Server already has multi-versioning, but it is not storing versions in persistent storage. So we store the versions in a persistent manner so that if the database goes down, we come back up, we do the analysis and redo. Now the database is in crash consistent state. Now we open up the database without waiting for undo. So if someone and customer can rerun the same transaction and they'll go ahead because the active transactions when the system failed, they were not going to block. Whoever comes to a row, if it needs to be undone, if it has uncommitted changes, they will do it. So it's a huge effort, and we're all very proud of it. Professor Andrew Pavlov from CMU actually covered this as part of Advanced Database Systems. We had a paper at VLDB 2019. And recovery time is not a problem for many databases today. Still, in case of standard where storage is remote, where checkpoints may not be happening, so the redo may take longer, but otherwise we are very happy with this improvement. The other problem it solved was prior to CTR, we used to have a lot of incidents where we were running out of log. And when we create the database, we size the log based on the SKU. But if the customer has an active transaction, or maybe even an inactive transaction, they started a transaction, went out for lunch, then it will hold up the log. And they will run out of the log, and we were getting incidents. When every week when we cover, okay, how many logful incidents we got? And engineer has to take the call and add more storage for the log and so on. So what we did here was we aggressively truncate the log. Because the versions are all stored persistently, and we also checkpoint the active transactions. So we don't need to actually have the entire log covering the active transactions. So this has been a huge lifesaver for our life site. So I'll give one anecdote here. When we were designing, just like in most features, we design for the common case. And the common case is transactions commit. They don't abort. So midway or towards the end of the feature, once we turn it on, we found that there are cases where there are too many transactions rolling back. So we maintain a water transaction table, and that itself was going to be multiple millions, and we had to checkpoint that. So we made some improvements so that if the transactions are short, then we actually undo as part of the transaction rollback itself. So that's kind of learning as we deploy and see how customers are using it. It's a huge learning experience for us when we turned this on. At that time, in summer of 2019, we had only 3 million databases. Well, 3 million databases was a big deal. And over 2-3 months, we could roll it out, fixing any problems. So this, I started the talk contrasting on-prem versus cloud. So this is something that you could never enforce on-prem because this feature is available in the box release, but it is not on by default. Customer has to enable, so which itself is a hurdle for getting the adoption. But here, now all our databases run with CTR on. I think I need to speed up. So I said we have 4 replicas for business critical. 2 or 3 years ago, SPO leader Naresh Kannan, he said, hey, why do you need 4 replicas? And everyone is trying to save money, right? So do you really need 4 replicas? 4 replicas cost. Why can't you manage with 3 replicas for the data, and the 4th replica could be for the log? So the problem is, why do we need 4? When we are doing upgrades, we need to bring down a node and deploy the new beds. So during that upgrade, if another node goes down because of hardware failure, then 3 replicas won't be enough. You're staying with 1 node. But you don't need a full database replica. You can do with logs. So this is an improvement that we did, and it's, as we speak, it's completing its rollout. So we run with 3 full replicas and 1 log replica. This has saved significant amount of CPU and memory and disk as well. I'll quickly cover query processing. Obviously, a big part of the database engine, and as we get experience with various customers, we made a lot of improvements on cardinality, estimate feedback, DOP feedback. You see feedback many times because that is the constant theme in all of these improvements, where we run the query and we get feedback from running the query on cardinalities, on did the degree of parallelism help, and how much memory it used. And if what we estimated before executing is very different from what's actually used, then we can actually use that feedback to improve the future runs of the query. So that's something that we are making use of in many improvements. And we use the QDS for storing the historical information about the plants and about the execution statistics and so on. So these are some of the improvements we made. I'll just talk about 1 or 2 of them. There is this long-standing requirement about parameterized queries. If you run a query, okay, show me all the listings by some real estate agent who is a new one. There may not be that many rows qualifying it. You may use a seek for that, whereas for some other agent, you may have a large number of them and you may use a scan. But if you did a compilation when the first query came, that is the plan you are going to use, because it has the same query except the parameter value is different. So we found this is a huge problem in many customer cases, in particular for Dynamics. So now we actually have multiple plans for different cardinalities and choose based on the cardinality estimate different plans. This is the query store that we have been making enhancements over the past few years, and for many of the QP features we depend on this. As the databases grow, some of the kind of tables that customer uses, they're also growing. All the utilities, I mean, maybe 10 years ago, a lot of them were often creating index would take a share table lock and you can't do any updates. So we changed it to online. But in the cloud, it might be a multi-terabyte table, and creating an index may take multiple hours, and in between, the system may crash because you're doing an upgrade or there was some other failure. So online alone is not going to help, because now you have to restart the whole work, and that is a significant amount of work. So we did resumable create and build index, and we did this 4 or 5 years ago, and as I showed you with hyperscale, now we are having really large databases. Without something like this, it would have been extremely hard for us to support. Let me spend a few minutes on some of the improvements we made in the area of security. We always had TDE, transparent data encryption, on by default. What it means is the data that is stored on disk is encrypted. Similarly, even the results that are given back to the client, they are also encrypted. But the data that is kept in memory is in plain text. So when we read from disk, we decrypt and then we operate on that. But as we started getting significant customers from banks and financial institutions, people are worried about, okay, it's a large service, there's a significant number of Microsoft people having access to the database. So what if they access in-memory contents and extract some of the critical information? And during that time, there were some leaks that were made public from some of the big vendors where some insider had leaked out customer data. So one of the major innovations, this actually came out of MSR. Raghav from MSR moved to the product team and delivered on this, where we have this concept of enclave, where some part of the data is stored in enclave. So that is not accessible to anyone, including Microsoft insiders. So for example, let's say, previously you could have something like Social Security, credit card numbers encrypted, and you could keep them encrypted in memory because you're accessing them for strict equality, and you can do that without necessarily decrypting it. But let's say you want to something like salary is there. Now, how do you can if you want to do a range query, then you cannot just use hash on that, right? So with something like enclave, you can store those things encrypted even in memory. Only when you want to do an operation, then you go into the enclave. It is in the enclave you actually decrypt. So this is a major innovation. Then we can actually claim that customers' data is always encrypted regardless of whether it is in transit, in memory, or on disk. So this is around 3-4 years ago. Blockchain technology was kind of the rage. Everyone was talking about it, and people were saying you need to have a new type of databases for it. So we said, okay, what is special about it? And yeah, it gives you stronger guarantees about security, but when we looked at the number of transactions they support, it was really pitiful. It was like what we used to support in the past century, even worse than that. So we said, okay, we definitely have high performant relational databases, and what is that customers are looking for? So we talked to the customers and we came up with this ledger-enabled tables in SQL, where we guarantee what is called forward integrity. So what it means is, while running the transaction, we expect that itself is a valid transaction. There's hopefully proper auditing and login authentication is done so that only the right person is doing the transaction. But after that, what we guarantee is whatever was done is going forward will not be tampered. So what we do is we get the digest of the transactions or the database and store it separately from the database. Now you can actually verify if someone tampers the database. So this is something recently Lenovo started using to make sure that throughout their supply chain nothing is getting tampered. Here is something based on our operations experience. Just before the pandemic, I remember it was actually close of Microsoft fiscal. There was a big customer that was supposed to close the deal. And as I said, it was around the time, it was actually a major bank that was rolling out their application. They already rolled it out to some branches. And then there was in the news that some insider at a public cloud vendor had leaked out the data. So they were very concerned. And they wouldn't sign the deal without better protection. So we came up with this what's called lockbox workflow, where even if there is, there are many cases where there are live site incidents and we have to have access to the database, and that's what our customers are concerned about. Okay, SQL itself is a large group, and there might be some disgruntled employee that might take customers' data out. So what this workflow does is, when we have a need to actually have access to the customer database, we create a access request, and that is actually sent to the customer, and customer has to approve for our engineer to have access to the database. And everything that the engineer does is actually logged, and those logs are shared with the customer so that they have complete control on what is being done to the database. So this is something that helped a lot of the big financial institutions to gain confidence in SQL Azure, that they can trust their data. Now I'll talk about some of the problems which I wish there are better solutions. I mean, typically we database folks don't depend so much on underlying operating system, right? We say, okay, give me a process and get out of our way. So we manage most of the stuff. But one thing we depend on the storage system is, when I say write this page, if you come back and say you have written it, then I assume you have written it to the disk and not lying to us by keeping it in some disk controller cache or something like that. When hard drives used to do that on IDE drives some 20, 25 years ago. So unfortunately, what we have found is, on some of the SSDs, they are not honoring the writes. They say that they have written, but it's not persistently written. So later when we go to that page, either our recovery may fail because it hasn't caught up, or there might be actually silent data loss. So it's an unfortunate situation, actually a very frustrating situation. I have asked many people within Microsoft, other Azure storage folks, they say they don't see this problem. So I don't know why only SQL is seeing it. So we actually put in a lot of engineering effort to keep track of what was the LSN for a page when we issued a write. So we store this in a separate table. And when we read the page from disk, we go and check, okay, is a page LSN up to date? If it is not up to date, then we have to either ask a secondary to see, okay, do we have this page up to the latest LSN? Or we may have to go to the backups, and I mean, imagine the amount of mechanism that we have to build to get around this problem. Even then, it is not foolproof, because we can't guarantee that for all pages that we issued writes, we are keeping track of them. So it would be nice if storage just honors the simple write. Jonathan.
Yeah, so this is a problem that you've seen at the level of individual SSDs when you try to write to them directly. Have you ever seen something like this when you were using like Azure replicated storage or anything like that?
Yeah, that's what I was saying. I talked to our friends in Azure Storage. They say they haven't seen this.
But I mean, have you ever read a page that you wrote to
Oh,
Azure
okay.
replicated storage?
Yeah, good point. Actually, that's when I did the weekly reviews, I always ask, okay, is this happening on local storage or remote? So most of the times it is on local storage.
But you do see it happen on remote storage too.
Occasionally.
Wow. Okay.
Yeah. So we asked the hardware folks. They asked, okay, give us a repro. We don't know how to give you a repro for something like this.
Yeah, that seems like it's a bug in Azure storage, right?
Well, one thing I've seen, and this is some years ago, is that actually the data was written to storage, but it was a corrupted address. And so the data was written, but to a different part
went to
of the
somewhere
device.
else.
So the device act, it got processed. Now, presumably you're supposed to have enough error correction bits to know that this is a vanishingly small probability. But Now you gotta really ask, at what probability? What
Yeah.
is the number? Because you're running at huge scale. It doesn't have to happen very often for you to actually see it occasionally.
Yeah. It's true that in case of SSDs, you don't write in place. You're writing to some other place, and you have to update your directory saying that, okay, this block is now here. But all of that is that storage system's job, right? Yeah, this is still a very frustrating aspect for us.
So one like follow-up question here is, any transactional guarantees that we give is modulo this problem not occurring. Is that correct?
Correct.
Okay.
That's why I said it's leads to recovery failures and data loss. It's actually silent data loss, which is a big concern.
And, just curious here, record the page at the center. How do you do that if writes may not go through, which is this problem? Like, how do you record this staging under where you know storage
Right.
on
As I said, it's not a foolproof solution.
Right.
So, but it has helped us, at least in some cases. Yeah. I mean, this problem has to be addressed by storage. I mean, as you know, most of SQL engine code is in C++, and which means due to some bugs, almost even senior engineers sometimes make mistakes, and it leads to memory leaks or double freeze and illegal accesses and so on. Unfortunately, they're not caught early on sometimes. In fact, a few months ago, we had a major incident after we deployed to most of our fleet. One of the customers was having database corruptions. Luckily, it was happening only on that customer because they were using a specific feature, and in that code path there was a bug. So this is something that we're very concerned about, because when we have multiple millions of lines of code. So we were trying to see, is there any way we can at least protect our buffer pool and log buffers? Then we are safe to the in the sense only the lowest level routines in access methods, they need to be careful. And Intel has actually come up with some technology called memory protection keys, where in their page table entries, the pages could belong to different groups. They support up to 16 groups, and for each group you can have different accesses, read, write, execute. Now the nice thing is, for each thread can say that, okay, for this group is a set of pages, I want a read, write access. So what we thought we could do was, in the access methods, there is a strict protocol to be followed. If you're going to change a page, then you get an exclusive latch to the page, make change, and then release the latch. So I said, okay, during that code path, we can say, okay, for this page table entry that belongs to, say, this group, I want to have read-write access, and then once I'm done, I'll do it. So we said, okay, if we have this protection, then at least the upper layers of the database engine, like QP and so on, if there is a mistake, they won't be corrupting buffer pool or log buffer. The problem is, if you corrupt log buffer, not only you're corrupting locally, but the log is replicated elsewhere, and that also corrupts, so all replicas might be corrupted. So we were encouraged to see this tech, but this requires operating system support. And we talked to the Windows folks, but they're very concerned about taking away the few bits that they have left in the page table entries. So that's still a concern for us. I'll quickly go through another thing that occasionally happens. This can easily lead to someone that you were asking about. As I said, everyone is making changes. It's I mean, even Windows operating system, okay, we do the major upgrades only once in a while, but there's a networking team, there is a storage team, there are various drivers. Everyone has a legitimate need, sometimes for feature enhancement, sometimes there is some major security issue that you just have to roll out the changes and so on. So we had a few incidents where DNS outage happened. DNS outage happened means it's a significant problem for a good part of the service. So what we did was we actually created a DNS plugin. Um, we worked with the with Windows team so that we could cache the DNS entries. So even if the DNS is down, we could make use of the cache and keep the service running. And this has actually helped us because there are at least 1 or 2 incidents in a year where this kind of outage happens, and we could keep the service running. Let me quickly cover a few more things. We have a small team of data scientists that are actually trying to help us in many ways. In helping migrations, they could actually collect the telemetry based on the workloads running on-prem and compare with the various queues that we have in the cloud and recommend to the customer. They came up with a benchmarking framework where they could evaluate how overbooking is performing. There's a tremendous amount of telemetry that's being used to help us quickly narrow down the problem. When we are doing a deployment, they can look at the telemetry and give us a signal whether it is safe to proceed or we should halt and so on. So this is something that we hope that can help us to the extent of if there is a dump, they can tell us, okay, this is the check-in that has caused this problem. Okay, let me spend a few minutes on one of the most important aspects of running the service, and that is deployment. As I said, we call them trains. Our hope is every 2 months we deploy a new set of bits. Imagine there are a few hundred SQL engineers working. So there's a significant number of changes that can go in within a matter of 2 months. So we have a well-defined policy. Actually, this is followed in all the services in Microsoft called safe deployment policy. We go through different stages of the fleet. There is canary. We deploy the bits, watch for a few days, see how we are doing, and then we go to what is called pilot, a few more clusters, then initial, and then heavy, and then bigger regions. If we go to Western Europe without any problem, then we say, okay, we can sleep for this train. Things should go smoothly for the rest of the world. But until then, there's a constant vigilance to see, are there new dumps, do we need to reset, do we need to take some fixes, and so on. And we should always be prepared to roll back at any point, even if you have gone through even beyond Western Europe. If there is a significant problem for a customer, we need to roll back. So we have whenever you are doing upgrades, we do this thing called two-phase upgrades so that we can roll back safely. So if you are doing any persistent data structure changes, you need to do it in 2 phases. First, you need to roll it out so that all replicas can understand, and then you actually roll the change so that even if you roll back, it is safe to do so. This is something, when I started my career in 80s, 90s, mission critical means banks, stock exchanges. We used to say, okay, they run only on Tandem or IBM mainframes. Would these workloads ever run on Oracle, Sybase? Microsoft was not even in the database business, right? But now, it's not that hard to get a maintenance window from Fidelity, but try to get a maintenance window from one of the gaming customers. It's really hard because they're always busy. So for some of these gaming customers, we just have to, we may have to keep the previous bits running. And one of the, when we go through a lot of trouble, the deployment is fairly involved. It's not easy for everyone to understand what all is happening when you're deploying across the whole worldwide service. But one thing I feel very good about is there's only two sets of bits running, either the previous train or the current train. So when there is a problem, we know, okay, what bits are running. It's not like there are arbitrary number of releases running in the cloud. That will be extremely difficult. We honor the maintenance windows, upgrade only during off hours, and some customers give us, okay, upgrade only on the weekends. We try to honor as much as possible unless there is a significant rollout that we have to do. Jonathan?
It strikes me that gaming is a bit different than the previous ones in the sense that like the availability requirement is clearly very strong.
Yeah.
Maybe they don't care as much about protecting data and that sort of thing in terms of losing data and that sort of thing. Is that right? Or do you?
I don't know. I mean, as a service, we say we never lose data, but from the gaming customers, upgrade means there is some downtime, and they're not happy because there are always some people playing.
Yeah, so the availability thing in total.
The availability is.
Yeah. But if they lose a little bit of their data, like maybe they're not as sensitive about data loss. Or something.
I don't know, depends on the gamer.
They're also, I mean, nowadays it's also, there's a lot of money involved also, right?
They suddenly get lost off the leaderboard because they dropped a few points, they'll be pretty unhappy.
They are pretty demanding workloads, and I think some of our high-end workloads are on that. Okay. So as I said, every 8 to 10 weeks we are deploying these new bits across the whole fleet, running pretty big customer workloads, right? So how do we make sure it is a stable build? And over the years, SQL has made tremendous improvements in how we build, how we test. I mean, when I was working on the box, getting a build, we used to take some days. Getting all the functional tests run will take more than a week, and so on. And nowadays we produce builds, many builds in a day. We run millions of tests on almost every build, and we go through various stages. There are lab runs, there are stage clusters. But despite all of this, we still face issues when we go into the production, because there's such a large variety of workloads running. It is difficult to test all of that. So here is a technique that's normally used in the industry, which is called A/B testing, where you have a paid up system with the new bits running, and you send the workload to both the places. And then you gather telemetry to see, is there a significant difference between the two? So we thought this could help us in detecting any regressions. But unfortunately, for something like a database system, the state is constantly changing. So it is difficult to make sure that your B is running on the same state of the database as the A. But if you're running mostly queries, maybe this is useful. So this is something that I feel more work needs to be done to make it easy for us to be able to deploy without regressions. But let me talk about something else that has been a huge savior for us. So this is called hard patching. What we see is, since we do very rigorous testing across so many stages, a lot of the times when we find a bug, it's not a major design issue that we have found suddenly. It is some simple bug. I mean, just yesterday we found a bug where a change has added an if clause but forgot to do the else clause, so it was returning status success rather than failure, and that would cause some problem in low memory situations, and we detected it only after 90% of the deployments are done. So now what can be done in this case? So we came up with this technique where if you're only changing a few lines in a function, then can you actually patch the SQL instance, hot patch, you're not bringing down the process, so that the call goes to the new version of the function that fixed the bug. So that is the idea behind this. It looks simple, but it required significant amount of innovation from compiler team, dev team, and ourselves. I think many other services needed, because you need to verify if hot patching actually works. I mean, not all changes can be hot patched. So there is rigorous analysis done to make sure what you're trying to hot patch is correct. So we get a hot patch build with the fix, and then we go and deploy, and it's kind of miracle. Your process is running, you replace with a new image, and this is, I think, one of the biggest features that came out of our operational experience, and it helps with every deployment that we have made. Arvind?
So this is not SQL specific by any means.
No, it's not
So,
SQL specific, yeah.
Is this solution like more widely available? Have they made it accessible to other, I don't know,
Yeah.
services?
Yeah.
Like the
It's
Visual Studio feature.
for definitely C++. So in conclusion, SQL Azure, it continues to evolve. There's tons of work for us to do in many, many areas. It's exciting for people like us who are devoted lovers of database systems. There's plenty of scope for innovation in database service. And I hope other people running database services can share their experience, because, and our field has grown because we have this tradition of scientific culture where we share our ideas. But with respect to operations, I feel there's not that much of sharing. Hopefully we can do that in coming VLDB and SIGMOD conferences to help ourselves and our customers. And for our on-prem customers, we are shipping stuff that's actually running on millions of databases. So it is much more robust than the releases we used to ship before the cloud. So for our product, for our customers and business, this is a huge, huge benefit.
Okay, you've got your hand up.
Hey, Phil, was that for me?
Yes.
Oh, hey, thanks for the talk, Hanuma. While you were talking about OB and serverless, right? I just wanted to call out that that's the result of a 7-year long or at least 8-year long collaboration with Vivek, Sudipto, Christian Koenig from MSR, and I would safe to say that I don't think we would have made some of those the intellectual breakthroughs without this collaboration. So I just wanted to acknowledge and thank them for that, and look forward to uh, to further breakthroughs here. And you guys will also be happy to know that a lot of the concepts that were developed for SQL DB are now getting pushed down to the platform there. So further proof. Thanks.
Thank you, Jay.
Yeah.
Thank you.
Almost every link I put in here, I'm sure has co-authors from MSR and GSL. So. Thank you. More questions? Yeah, we have a few more minutes.
Yeah, so I guess so SQL has been around for a while. The code has evolved over several decades now. So my question was like, and there are of course newer database engines being designed. If there were one component that you would name in SQL which you think requires a significant redesign in SQL Server, what do you think that would be?
Well, if you look at the features that I have shown, we did major re-architectures across all core areas of the engine. Story engine, query processing, resource governance, utilities, security, you name it, we have innovated. But if your question is, okay, how are you able to do that? How do you compete with the new players given that we have 25-year legacy? This is something that we debate, we struggle. People say, okay, should we do re-architecture? My answer, we are continually re-architecting pieces. A whole scale rewrite is not feasible given the scope of the technology, business, customer impact, and so on. But we are open for any suggestions on what can be done. We are talking to other people to see is there some way we can incrementally write some components in Rust so that, for example, the memory corruption bugs can be avoided. There are some people who want to, who are suggesting we can re-architect so that some parts of QP can be isolated from others. Yeah, if you are starting fresh, but even if you look at the people who are starting fresh, they are not starting from scratch. It's not easy to start from scratch and build a relational database engine, right? They're all taking Postgres open source and making some changes. So
can I ask you for doing one thing? Can you give a quick call to Hafiz? And no, I'll tell you. You tell them that you had sent this check.
Surjit, you're broadcasting.
So I don't know if I answered your question or.
No, I think that was useful.
Tariq?
Yeah. Thanks, Phil. Hanuma, you mentioned about re-architecting the system, and also like part of my question is due to, like you mentioned in one of your slides about the CE and DOP feedback, right? So in research in last few years, there's been a lot of focus on data-driven or ML-based solutions, right? So I was just wondering, what's your take on those solutions, and has there already been some effort within the SQL Server engine to make use of some of these data-driven techniques to to improve the QP or auto tuning or other features in the system?
Yeah, I mean, definitely this is what I tell my QP folks. We need to show that we are using ML. When I go to conference, look at the papers, everyone is using ML in some form or other. So there is definitely an effort. Please work with us. I don't know if Vasilis or Craig are online. I told Naveen that over the next year he needs to focus on making use of ML to improve our query processing. Anyone from SQL wants to comment?
I mean, I would say that in query processing, but then as well as in resource management, right? Given that we have intimate knowledge of the resource consumption patterns, there's a huge opportunity. I mean, we've taken a few baby steps, but there's a lot more that needs to happen there. Yeah.
So one question we often think is, like, while developing such solution is how hard it is for us to, even if we develop a very successful technique, how hard it is for us to integrate those techniques, those ML techniques inside SQL Server engine, right? So
That's what we can have a chat offline. But the implementation needs to be, the evaluation needs to be very fast. You can't slow down the main request path, right? But yeah.
Thank you.
Surjit?
Yeah. So Hanuma, to your point about QP improvement, not ML or not ML or deep learning or not deep learning aside, how much of the telemetry, because of the eyes of nature of the data, you feel we are hampered, or you feel that the telemetry without perhaps the full details of the queries and the data sets make our ability to do so-called intelligent query processing difficult, or you feel there is enough first-party workload to make that work?
I mean, my experience is, I was saying in during the talk, the telemetry has been extremely useful in designing various features. I cannot tell you about some of the stuff, but we deployed something up to canaries, and that was not even a significant part of our workload. And we could already see, okay, we were having some issues for certain types of queries, and we are discussing, okay, how can we mitigate that? I mean, lack of telemetry is I don't think is an issue. I don't know if any QP folks want to comment if that's a problem for us. And we have full control on how much telemetry we want to get, right? I mean, I know that there are some concerns about the cost of generating too much telemetry, but if you want to work on certain feature for that particular aspect, you can go and add. So that has not been a hindrance, and I don't think that should be a problem for innovating on the QP side. Anyone from SQL?
I don't see any hands raised.
Yeah, well, my question was more around, not getting full, yes, telemetry, yes, in terms of many of the details we can get, but not perhaps the query text, the data, and so on, which makes certain kind of, if you think about.
For the privacy
So
reasons.
those are different kind of data. If you don't have access to it, it might hinder certain kind of tuning and certain kind of feedback mechanism. That's all I was asking, whether that holds you back or you find that's not an issue.
Yeah, that probably is the problem, because we have to honor PIIs. And,
that's the point. That's the question I was asking.
But my take is we have a variety of workloads even within Microsoft instances.
Right.
We can partner with others. Yeah.
Okay, thank you.
Okay, one last question.
An open-ended question. Looking ahead, what are the major uncertainties you see? And I don't mean on the business side, of the technology and research side, right? So what do you see as promising areas?
Well, rather than promising ideas, also what is important. We need to keep the system available all the time. I think Jim Gray in his Turing lecture said, okay, system should fail only once in a century or something like that. And I don't know how to get there. I mean, I asked Professor Michael Hicks from University of Maryland, who was doing this dynamic software update work, to come and spend a week for us and tell us, okay, what can we do to, I have a few hundred engineers making changes to multi-million-line code base, how do I keep this stable? They have done some work, but it wasn't directly applicable to SQL. And we came up with hot patching, which is a savior, but only helps in limited cases. How can we do rolling upgrades? How can we keep the system running without any downtime? I think that's an important problem to be solved as the service grows. That's one area. The second area is, as someone asked, still incidents come and it requires a lot of engineers' time. I think we all need to have the goal of system. I mean, we have been talking about self-managing systems. We are not there yet. It's something, I mean, Surajit is online, we talked about, I mean, we have been working on index recommendations. I think we turned that on, and I was asking just a few weeks ago, okay, how many recommendations are actually followed by the user? Are we in a situation where we can run in auto mode? We are not able to confidently say, yeah, let's turn on the auto mode. And one good thing is, when you are responsible for multiple millions of databases, you think twice, okay, if I want to turn this on, am I going to get a plethora of incidents next day?
Yeah, 1% of the customers reply, you're overwhelmed, you can't handle it.
Yeah, so I would say automatic management of databases. I mean, people are coming to the cloud, they're not having a lot of DBAs, and they expect the system to run without constant tuning by themselves. And this, I think, has a lot of opportunities for us. All right.
Okay, we should stop.
All right, with that, thank you very much for an
Thanks very
engaging
much.
discussion.